Hello everyone. In this module, we are going to understand angle of contact. Now before we start with the angle of contact, first of all we need to understand what is meniscus. Meniscus in the plural form is known as menisci. It is derived from the Greek word crescent, which means the curve formed on the upper surface of the liquid close to the surface of container or any other object, and it is caused by surface tension. In the simple words, we can say that meniscus is the curve formed on the upper surface of the liquid because of surface tension. Now it can be either convex or concave. A convex meniscus occurs when the molecule have a stronger force of attraction between them. That means force of cohesion. It is the force of attraction between the molecules of same substance rather than the force of attraction between the liquid and the material of container, which is commonly known as force of adhesion. So here we can see in the diagram two test tubes A and B. In the first case, the meniscus formed on the upper surface of the liquid is concave, and in the second case, the curve on the upper surface is convex. The shape of the meniscus is concave because the molecules of the liquid are continuously experiencing the force of attraction or the pull between the molecules of glass container and the liquid. And in the second case, in case of the convex meniscus, the force of attraction between the molecules of the same substance is more. That means the force of cohesion is more as compared to the force of adhesion. That is why the molecules of the liquid are trying to acquire the minimum surface area and are closely packed. Okay. So that is why in the first case the meniscus formed is concave, and in the second case the meniscus formed on the upper surface of the liquid is convex. Now to understand the concept deeply, we should understand the intermolecular forces in detail. Now there are two types of the intermolecular forces. First one is the cohesive force, second one is the adhesive force. Now we will discuss one by one. The first cohesive force, it is the force of attraction between the molecule of same substance. Now here it is represented in the diagram with the blue dots you can see, and the force of attraction which is represented by these yellow arrows, these are the force of attraction between the molecules of the liquid or molecule of same substance. So it is known as cohesion or cohesive forces. Now these forces are strongest in case of the solid. This is the reason why the solid have definite shape. Now in the second case, that is the adhesive forces. Here the force of attraction between the sides of the container and the liquid present inside the container, that means it is the force of attraction between the molecules of different substance. This is known as adhesive force or the force of adhesion. So if the cohesive forces are stronger than the adhesive forces, the body of the water will maintain its shape. As shown in the second diagram, a liquid drop on the surface of a leaf. In this case, the force of cohesion is more, that is the force of attraction between the liquid molecule is more. Because of that, the molecules have acquired the minimum surface area and maintained its spherical shape. Now if the opposite is true, that is the force of attraction between the liquid and the surface is more as compared to the force of attraction between the liquid molecules, in that case the liquid molecules will spread out and will try to increase the surface area. So as shown in the first diagram here, because of the force of adhesion is more as compared to the force of cohesion, that is why the surface area of the liquid droplets has increased and they are sticked to the surface of the glass. Now it can be explained on the basis of the forces acting on the liquid drop. Now here in the first case, the three types of the forces are: first one represented by the yellow arrow, the force of attraction between the solid and the air. Second one represented by the pink arrow is the force of attraction between the liquid and the air. The third one is the which is represented by the blue arrow is the force of attraction between the liquid molecules and the solid surface. Now here we can see the magnitude of the force of attraction between the surface of the liquid and the surface of the solid is more as compared to the force of attraction between the liquid molecules. That is why the surface area has increased and the shape is not a proper spherical shape. And in the second case, because of the force of cohesion is more, that is why the liquid molecule has maintained the shape and are spherical in shape. Now here we can explain one more concept, that if any substance that we can add to the liquid that allows the liquid to increase the surface area, that substance is known as the wetting agent. So some fabrics are non-wetting fabrics and some fabrics are wetting. For example, we can see in the rainy season the raincoat, the umbrella, they are non-wetting fabric. As shown in the diagram also, on the non-wetting fabric, the liquid drop will maintain the minimum surface area and will not stick the surface. Next is angle of contact. The angle of contact between the solid surface and a liquid surface is defined as the angle made by the tangent drawn to the free surface of the liquid at the point of contact with the solid surface in contact with the liquid. In simple words, we can explain from the diagram. Here, the concave meniscus is formed on the upper surface of the liquid. So, the tangent drawn to the free surface is inside the liquid. Now, the angle of contact at the point of contact between the liquid and the solid surface is the angle made by this tangent with the solid surface in contact with the liquid. That means the solid surface here which we are taking into consideration is the solid surface inside the liquid, not the upside. It is represented by theta, and this angle of contact depends upon the cleanliness of the solid surface, the nature of the solid surface and the nature of the liquid and the medium above the free surface. Angle of contact can be acute angle or obtuse angle depending upon the type of meniscus formed on the surface of liquid. Now here we can see in the diagram concave meniscus. Now by definition, the angle of contact is the angle between the tangent drawn to the free surface of the liquid, which is inside the liquid in this case, with the side of the solid surface, with the surface of the solid inside the liquid. Here the angle of contact is less than 90 degree. So when the angle of contact is less than 90 degree, that is acute angle, then the liquid form a concave meniscus. In the second case, we can see the convex meniscus. Now in the same way, the angle of contact is the angle between the tangent drawn on the free surface. Now here tangent to the surface is on the upside because the convex meniscus is bulging outward. So that is why we have drawn the tangent in the outward direction. Now the angle between this tangent and the surface of the solid inside the liquid, we can see from the diagram that this angle is greater than 90 degree. So when the angle of contact is obtuse angle greater than 90 degree, then it will form a convex meniscus. For example, the water glass interface forms a concave meniscus and the mercury glass interface forms a convex meniscus. This is because of the intermolecular forces present inside the liquid, that is water, is less as compared to the intermolecular forces present between the mercury molecules. So that is why in case of the water the concave meniscus is formed, and in case of the mercury we can see convex meniscus.